What is up, everyone? It's your host, Carlos Ponce here. We are in another episode of Advancio Talks. This is a live show, and we've got an incredible guest with us today, Irv Lustig. I'll let him introduce himself in a minute. But let me tell you this, if you're just discovering us, welcome to the show. But if you have been here since the beginning, you know exactly what we are about. So, a quick rundown for the newcomers. Advanced Talks is where we sit down with the people actually building the future of technology in different spaces and verticals. Not just about talking about it, but doing it. You know, CTOs, founders, innovators, basically the folks making decisions that matter and driving real change in many industries. So we bring you conversations with visionaries, operators, and leaders who are shaping tomorrow's business scenario and technology scenario as well. So people with real stories, real results, and insights you won't find anywhere else. So whether you're drinking your morning coffee or commuting to work or just curious about what's actually happening, you are in the right place. So we got stories and insights coming your way that you definitely don't want to miss. So let's jump right in. And we got Irv Lustig. Irv, welcome to the show. It's a pleasure to have you here.
Well, thank you for having me.
Absolutely. Yeah, Irv. Well, first of all, folks, Irv is the optimization principal of Princeton Consultants. And I'm going to let Irv introduce himself. So please, Irv, tell us a little bit about you, your background, your journey, how you got here.
So thanks, Carlos. I guess I'll go forward in time. I got my PhD at Stanford University in an area called operations research, which has as a subfield optimization, which is where my expertise is. I was a professor at Princeton University for 6 years, and then I took the research that I was doing, brought it to a small software company called Cplex Optimization Inc., which got acquired by iLog and eventually by IBM. I had various roles from developing the software to being a product manager to being leading up the sales organization. Then at IBM, involved in the transition and had to learn teaching IBM about the business. Then pivoted back to my research roots. I was in IBM research for 3 years. And then about just over 10 years ago, I joined Princeton Consultants to get on the other side. Instead of worrying about developing the software and selling the
Mhm.
software and marketing, got involved in being more of a consumer and developing solutions for customers that would leverage the technology that I helped build and sell over a long number of years.
Mhm. Great. Thank you for sharing that, Irv. Now, tell us about Princeton Consultants. What is your value proposition? What problem do you solve? Tell us a little bit about that, please.
So Princeton has been in business for over 45 years. We were founded as a management consulting company in the early 1980s. And as the business grew, we started recognizing the value of leveraging technology to help companies make better decisions. So even before I joined 10 years ago, we were doing a number of different projects in optimization, as well as projects that have no analytics, no optimization,
Mhm.
but that help companies rebuild, apply IT in different types of ways, in different operational types of
Mhm.
systems. Um, and then when I joined, the idea was to help grow the optimization part of the business. So we look at problems where companies have to make decisions and need to kind of more automate these decisions. And in optimization, it's typically about making decisions on how do you best allocate limited resources. So we've solved problems like in finance, you can think of the asset allocation problems. How do you allocate your portfolio? Or we're doing work for a medical company that has to schedule patients and the workers who take care of those patients. We've done a project. We did a project we were part of with the United States Census Bureau for the 2020 census, which was re-engineered. Every census has a bunch of enumerators that go knocking on people's doors to get answers from the people who don't respond to the census. So the census re-engineered this process in 2020, and the enumerators was about would go out and get an algorithm on their phone that would say, go to this house next, then this house. And it took out about $2.5 billion of cost out of the census that was done in 2020. And in fact, it turned out they really needed that technology because the census was supposed to happen in April, but there was this little thing that got in the way called COVID. So when they ended up executing the whole enumeration process in October, really from August, October of 2020, they used that system to be able to make sure the enumerators were doing their jobs as efficiently as possible. So we work on problems like that for our customers to help them, re-engineer their businesses so that they're making better decisions, saving money, increasing revenues, etc.
Irv, thank you for also for telling us a little bit about Princeton Consultants and shed some light into what your company does. And I didn't know it was around. It's been around for a long time. 45 years. It's a long time. Uh, okay, now let's move on to the today's topic, right? So we're gonna be today we're gonna be talking about how advanced analytics transforms travel technology, or in other words, what I call the dizzyingly fast changing scenario of AI in the travel technology, for example. So the first question that I have for you, Irv, is can you let me put it this way? Can you can you walk us through how optimization works behind the scenes? For example, at airlines, what problems are they solving in their back office operations that passengers never see, for example?
For sure. One of the some of the operational problems. So one of the problems that has been probably done for decades at this point by all the airlines is what's called the fleet assignment problem. So if you imagine you've got a whole schedule of flights that you want to execute over the next month, and what you need to now do is allocate planes to those flights. So what does
Hmm.
that mean? If you're an operator like American Airlines or Delta or United, you've got planes of different sizes, and you want to basically they have to go on route. So if you take, say, American, they have a plane here that's in Miami, where I am. That plane might go from Miami to Orlando, maybe then it goes to Dallas, then to LA, etc. It has to be scheduled for maintenance. It also You also don't want to put a big plane that has a lot of capacity on flights that have low demand, nor do you want to put planes that have small capacity on flights that have a lot of demand. So this problem, it's a big optimization problem, is to efficiently schedule and allocate the tails. That's the idea of a physical, actual plane to flights and the sequence of flights that it will go through to make sure that when it lands in one airport, there's enough turn time to get the passengers off, clean the plane, get the next set of passengers on, and move on to the next flight. So this is a problem the airlines solve every month, maybe even more frequently, to make sure that they can run the airline in an efficient way. Another related problem is what's called crew planning. So your crews, separately, you have the pilots and then you have the flight attendants.
Hmm.
They need to be assigned to those flights. So the flights are given. Now the crews, of course, you have to say, okay, here's our crews that can go on 737s. So let's look at all the 737 flights that you just got out of the fleet assignment problem and decide, how do we want to route crews? And they have all sorts of rules, like they can only work so many hours in a day, and how many hours need to be, how rest they would have after, saying, a sequence of flights, etc. So they come up with a set of what are called rotations. And now, how do you allocate those to the flights? You have to make sure you've got the right number of crews in each flight, not too many crews. You want to avoid what's called deadheading. I'm sure we've all been on flights where you see a pilot or a flight attendant. They're on the flight, they got their luggage, but they're not working. That's called a deadhead, because they got to get back to their home base. So all of that is solved as an optimization problem so that the crews are efficiently allocated to the flights. One that we see as consumers is what's called is revenue management, which has two parts. One part in revenue management is to decide, they have what are known as fare classes. So they will kind of say, we're gonna have these fare classes, and these are the fares for those classes. In the old days, you would have three or four fares available in a coach. You have one fare for first class. That would be it. Now, if you try to buy a flight and you actually look at the fare rules, you'll see there's something like 15 to 20 different fare classes. Somebody today in some back office goes through and determines what the prices are for each of those fare classes. So now Imagine you have a plane and you want to decide how many tickets should I offer at each of these fare classes. And
Mhm.
so the revenue or yield management, revenue optimization comes under different things. It's introduced by American Airlines back in the 80s based on optimization. And the interesting problem there is if I have a plane that's going from Miami to Dallas, there's going to be passengers on that plane that get off the plane in Dallas, but there's going to be other passengers that go and connect to another flight. So when I'm allocating seats onto that Miami Dallas to the different of how many tickets I want to sell at different fare classes, I'm not just worried about the Miami to Dallas passengers. I'm also worried about the connecting passengers.
Mhm.
Now expand this to a huge network. There's other passengers coming from other places into Dallas to make changes. This is a big optimization problem to determine how many seats to allocate at each one of these fare levels. So often when you'll see things, you'll look and you'll say, wow, there's not a lot of seats. A lot of seats are available on this plane, but why is the price so high? Well, they've estimated that the demand is going to be higher and people will be willing to pay more. So they allocate more seats at the higher price levels. And this is all being done with analytics behind the scenes. The part that's new that's coming on that I've just read about, which is interesting, is trying to determine what the prices should be on those fare classes using some other types of analytics, which people are a little worried about, like, well, they know that you're a frequent flyer on the airline, so they're going to offer you a different fare than somebody else who's a vacation traveler who rarely travels. So they might start doing some profiling and then only showing you fares at certain classes based upon your profile. A lot of people are talking about the ethics of this, whether it'll be okay. I've just read about it. I'm not involved in it. I understand how the optimization works. And I would also say that one of the things that happens in this revenue management area in the airlines is it used to be something that would be run like overnight, sometimes even just once a week because there were hard problems to solve. Now they run it much more frequently. They'll redo the allocation of seats to fare classes more frequently. I'm not exactly sure how. I think each airline has their own different approach, and they're also looking at using analytics to determine based upon what is the demand signal that they're seeing for that flight. So if a lot of people are looking up, say flights to Miami to Dallas on a specific date, they might then start adjusting how what the demand based on the demand signal how many seats they're willing to allocate to each one of those fare classes. So this is all happening behind the scenes.
Mhm.
What makes airlines run every day. Another problem that they're solving, which has recently come up, is I've seen both American and the Lufthansa group do this. Is um, how to handle disruptions. So you've got some storm is coming, and you know you're going to have to cancel some flights. Which flights should you cancel? How do you know based upon what passengers are on those flights, also where those passengers have to go, especially if the flight's coming into a hub, like say American going into Dallas, got a lot of passengers coming there, got to be careful
Uh-huh.
about which flights you cancel because you also have to worry about the crews and you got to worry about those planes that you've already assigned to flights that you did earlier in the month. So you got to redo the problem and adjust the plan schedule. So this is something now that some the airlines are looking at more is
Mhm.
handle this problem of disruption so that we're taking care of our customers because they want to be customer first, believe it or not. But also how do we handle our operations as well?
Okay. Yeah, that's as far as the airlines. What about hotels? For example, hotel revenue management.
They do
Uh,
a very similar type of thing. So they're looking at if they look at demand at a hotel, you have people who are just staying for one night or 2 nights or 4 nights or maybe a week. So if you imagine you've got a certain number of rooms, and again, you've got different kinds of rooms. You've got rooms with two double beds or one king bed, or sometimes you have suites, etc. You try to forecast demand in the same way we forecast demand for airline flights, and then you want to allocate the rooms. And so the hotels generally run that as an overnight thing to determine. There's one hotel chain that I remember hearing a story about. You know, if you look at the big hotel chains, they own a huge number of properties across multiple brands.
mhm.
And so what they do is they run an optimization per property overnight. Just use the cloud, fire off a whole bunch of different computations going on so that the prices for the next day are set. So it's the same
Mhm.
kind of concept is how do we allocate our inventory? One of the interesting things that's true in both the airlines and the hotels is this inventory is what they call perishable, which means for an airline, for an aircraft, once that aircraft takes off the ground, the inventory's used up. So if it's 75% full, you didn't sell the other 25%. Same thing is true with the hotel.
Mhm.
Once that day passes, your inventory is gone, right? That's a little bit different than determining pricing, say in retail, where if I have a set of goods in my store, right, the inventory doesn't go away until it's all purchased, or I decide to shelve it or throw it away. But time in both the airlines and the hotels is what's making the inventory kind of perish, and so they are taking that into account in their models.
Mhm. Mhm. And how do airlines use optimization for crew scheduling and aircraft routing, for example? And what makes these problems so mathematically complex?
Well, so if you think of on the crew scheduling, let's take that, right? If I know my set of flights and I've got my crews at different bases, because crews generally live in a certain, generally in the hubs, but other places as well. I now want to. It's sort of like taking a route. Like if you think of your driver that like at UPS that delivers has to go and make a bunch of stops, the crew has to make a bunch of stops. They have to go from one flight to the next flight to the next flight. Well, how do you connect all of that together into a sequence of flights, making sure they come home, making sure they're working not too much, but working enough that it's because I believe the way they're paid is they might be paid for certain hours of the day, whether they're in the air or they're sitting on the ground waiting for the next flight to take off. So you want to maximize their usage. So putting together all of those possible combinations makes it really hard to enumerate what are the possibilities, and optimization is really good at figuring that out. The
Mhm.
same type of thing is happening in that fleet assignment problem of determining the planes. Think of the way this used to be done before optimization came around. They would go into a big room, maybe the size of a football field. They would put pins in the ground for each of the locations. They would take different color yarn to correspond to the flights, and they would use the yarn to go from one city to the next to represent a plane. So they would say, this is a route for the plane. Well, now
Mhm.
imagine that kind of problem. You want to get all your flights covered, but if you're running 1,000 flights a day, that's a pretty hard problem to solve.
Yeah.
So this is where the math comes in to help figure it out and decide what's the best way we should allocate our inventory of planes to this set of flights that we've already scheduled.
Right, right. Great. Now let's. Uh, those are the good insights, but let's talk about the people. The teams. Uh, can you share your thoughts on, for example, when building distributed optimization teams? What are the communication patterns that work best for complex mathematical problem solving?
So we use a variety of techniques. I mean, what's important for us is first to understand the business problem. We've got this great set of tools that can solve problems in the optimization arena, but not just that, whether it's machine learning or AI. We've got all these great things in the tools. And there's a lot of people who basically say, I've got a hammer, let me find a nail. We do the opposite. We find the nail. We're trying to say, what is the problem you're trying to solve? What is the current state of where things are? And is there a potential way of doing things that are better so you can make better decisions that are going to deliver value? We then try to translate that business problem to we're doing a lot of interviewing, and then that's the nature of consulting. You interview, you talk to the experts. How are they making decisions today? And then move into framing it as an analytics problem, getting data, making sure the right data is available to help you make decisions. If you think about like that airline fleet schedule assignment problem, you have to determine, well, what do I think is going to be the demand for each one of these flights? Because that's a key input to understanding if you're going to put too big a plane or too small a plane on a flight. So you work with data a lot. We spend a lot of time with that. And then you go out and you start picking a methodology, developing a model, building an application that somebody can use with user interfaces, and making sure it can be maintained over time. So in terms of the teams, we generally work on most of our projects with pretty small teams. Could be anywhere from 2 to 3 to 5 people. Some people are totally responsible for things like user interfaces and data and databases. Others are optimization experts like myself that worry about the optimization. We'll have different business analysts involved. And now, because before the pandemic, we used to do a lot of work on site at our clients. Everybody's kind of gotten used to this virtual way of working with customers and collaborating together. So we do a lot of virtual meetings using, technologies like Zoom or Google Meet and Teams, etc., where we meet with our clients that way. We have one client that I've been working with for the past 5 years. Um, we had an agreement prior to the pandemic that we were going to start this project. The pandemic hit, they delayed a little bit, and then we got to starting it. And I think it was like September of 2020. Well, nobody was flying and meeting anybody then, and so we did all our meetings virtually. I have still yet to meet them in person. We have these meetings with 20 people from their side and our side all together, collaborating, figuring out how do we make things work and how do we meet requirements. Now we're in the process with them where it's in a pilot phase and we're getting feedback, and everything happens virtually. So, we've become more adept, I think, and not just us, I'm sure a lot of companies going more adept. How do you manage remote teams and how do you work and collaborate in a remote environment without all
Mhm.
being in the room at the same time? And technology has been a big help in allowing us to do that.
Absolutely. Now, regarding the let's talk about a little bit of in the applications, industry applications. For example, uh, beyond pricing, where else do you see optimization making a significant impact in airline back office operations?
Well, I think so. These applications that I've mentioned are happening. What's one of the ones that's starting to occur now is this disruption one that I mentioned. I mean, that's relatively new that that they're trying to look. It, Actually, there was a project that was done about 20 years ago by Continental Airlines before they were acquired by United, that was used when, like, as a response to, say, a hurricane in Houston or a blizzard in Newark, and they only worried about the operational side. So, and they also used it on 9/11, right? So 9/11,
Mhm.
the airlines were shut down for a few days. How do they get back? And so the whole idea was, well, how do we get a new fleet schedule, given that we know where our planes are and we know where our crews are? How do we get the airline back up and running? But only worried about the operational side. These new applications that I mentioned that both American and the Lufthansa group have done, which I've only heard about in the past couple of years, are how do we accommodate the passengers too? Let's not just make this about how we run our operation, but let's also understand the impact on our passengers. So I
Mhm.
think there is more things where the airlines are starting to look at the passenger side of the effects of their decisions, as opposed because operationally there's a cost, right? But if you affect your passengers, it's going to affect your revenues. And so it's to
Mhm.
trying to
Right.
make those appropriate trade-offs are some of the new things that we're starting to see, in that industry. The airlines have been one of the places that have been using this technology for, decades now,
Mhm.
where you're starting to see it though in other ways. I mean, if you take companies like Uber and Lyft, behind their decisions of what cars get assigned to you as a passenger and to the drivers is the same kinds of technology. So you find people with new transportation, new ideas that are happening, coming up with and finding new ways of saying, "Hey, this technology can help us make better decisions."
Excellent, excellent. Yeah. And well, I think we got time for a couple more questions because we're approaching the final segment of today's podcast. But I think that I would like to continue with asking you about implementation. For example, how do you validate that an optimization solution is actually improving business outcomes versus just producing mathematically optimal results?
So there's a couple of things that we do. One thing we do is I mentioned, like, at that interviewing process, we always try to establish a baseline. So how can we, first of all, we have to determine, can something be measured, right?
Hmm.
So once we determine, and not just something, usually there's multiple KPIs, key performance indicators, different things that have to be traded off. Sometimes, it's everybody wants to maximize revenue and minimize costs at the same time, but you're sometimes trading off these types of things. Or another example is um, in is service requirements. So, or take the problem of that we talked about earlier of the disruption of an airline. they're trading off what happens to our passengers, but what do we do to our operations? So you understand what those KPIs are and establish where we are today. What are the baselines? Now, if the technology gets implemented and it's making better decisions, now you have the opportunity to compare those key KPIs that come out of the decision and
Hmm.
say, are they better? Right. And sometimes it's not just quantitatively, but it's qualitatively, because we're working with this client right now that is has a scheduling problem, and what they have current schedules that need to be modified. So one of they have a metric that measures the quality of the schedule. But the other metric is, well, if we have this current schedule, how do we modify it? We may have to make some moves. If there's too many moves, there's a cost. It's not a dollar cost or anything, but it's a, you know, uh, warm and fuzzy cost, maybe if you want to
Hmm.
call it that. So they look at answers, and we give them all these metrics, and they look at it and say, this is the one that feels right. They can do their own qualitative evaluation, not just quantitative. But typically in optimization, we have quantitative measures that allow you to see. And then we also build things that validate. When we're doing optimization, I mentioned it's allocating the resource. What's the best way to allocate resources under some constraints? So
Hmm.
we're making sure that the decisions we're making are satisfying a set of constraints. We write technology wise, we call it a solution validator. We take a solution that comes out of the optimization engine. We have a non-optimization person, right? A validator that takes the same input, takes the answer from the optimizer and says, does it follow all the constraints? But he can't look at the optimization code. He just looks at the business requirements that we wrote up from that first interviewing session that we did at the beginning.
Hmm.
So it's a way of making sure that we're valid, that we're coming up with something that's valid with respect to the business requirements, and that it's delivering the value along these various KPIs that they're interested in.
Absolutely, absolutely. Well, Irv, I'm afraid that all good things must come to an end eventually, and we need to wrap up. But I would like to ask you some final words of wisdom for the audience about optimization in general and how it applies to your industry. Anything you want to say to the audience that you want to leave them with about you, the topic, or the company? Anything that you consider that the viewers are going to remember you by?
Well, so in today's world, we're hearing a lot of hype about AI, especially Gen AI, et cetera. Optimization has been around as a technology for, now let's see, I would say 70 years or so. I mean, it's getting close to, yeah, about just 70, 75 years, been around for a long time. The value of it is proven every day by lots of companies. It's kind of the thing that is hidden, and yet it really is something that delivers incredible ROI, return on our investment. Also, another measure we use is time to payback. If you do the investment, how, of it costs you so many dollars to have a system built that solves a problem, how long does it take you to recoup that investment because you're making better decisions? And it's not just about making better decisions that might improve profits or service or what have you. Sometimes it's also, can I make the decision faster
Hmm.
than via doing something in a spreadsheet or on a piece of paper or yarn on pins inside of a big gymnasium? I mean, it's all about making better decisions, and it's kind of an unknown thing that it's actually there and delivering value. So I hope our listeners today realize, like, hey, you might have an optimization problem because you're sitting there figuring out a schedule by yourself on a whiteboard, or doing something Excel trying to say, how should I make this person do this work, what have you. These are all optimization problems, and companies like ours, can
Hmm.
help you recognize that these are problems that we can help you solve.
Absolutely. Well, Irv, it's been a pleasure, and but I need to ask you how can folks who might be watching now or in the future, how can they get a hold of you? How can you be contacted?
Well, so I think you've been running some ribbons along as we've been talking here. We have a website. It's princetonoptimization.com. It is there. We've included an email address of our business development group, which is BD
It's
at
just right there.
princeton.com, right there on the ribbon there.
Yes.
And so those are probably the best ways to get in contact here with us in Princeton. And if
Are
you, do so, our business development team and myself will be involved in having further conversations about your business problem.
Absolutely. And I'm assuming you're on LinkedIn as well, right?
On LinkedIn as well. Yeah, I'm pretty easy to find. There's not too many Irv Lustigs in the world.
Well, here it is. Let me just share it with you folks. There it is. It's Irv Lustig. It's easy to remember, and I think it's even musical. Irv Lustig. It sticks, right?
There you go. And also, that's what I wear. I also wear. Everybody knows me by my hat. One thing I like to say is that
The hat.
is I want you wear a hat. I said, well, one reason is like I wear the hat because now you'll remember what was it that guy with the hat was talking about.
Yeah,
so
there you go.
That's part of the reason I wear the hat.
There you go. Yeah, I know how that feels. I mean, I'm the guy with the black hair and the white beard. It's like, the guy with the black hair and the white beard. Yeah, that's me.
There you go.
Yeah. Okay. Well, first of all, thank you so much. It's been great to have you on the show. And for those of you who are watching, please please to visit advancio.com/tech talks for upcoming interviews on what's going on in the tech and world and other industries and other business spaces. And it's right there. You can just go there and take a peek at what scheduled conversations we're going to be having soon, including next week's right here on Advancio Talks at 11 o'clock Mountain Standard Time. That being said, Irv, thank you big time for having been with us on the show. It was a great pleasure, and we'll see you next time. Please, Irv, stay with me as we go off the air. The rest of you, see you next time.
All right. Thank you.